Greetings, my name is Royce Bumagat, and now I'm gonna present to you our coursework number 3, Digital Subscriber Lines. So let's get started. Digital Subscriber Line, or what you call DSL. Digital Subscriber Line is a family of technologies that are used to transmit digital data over telephone lines. In telecommunications, marketing, the digital DSL is widely understood to mean asymmetric digital subscriber line, the most installed DSL technology for internet access. Next, this is the types of DSL technologies. One is RADSL, or Rate Adaptive Digital Subscriber Line, ADSL, or Symmetric Digital Subscriber Line, ADSL Lite, or G Lite, HDSL, or High Bit Rate Digital Subscriber Line, IDSL, or what you call ISDN, Digital Subscriber Line, and lastly, SDSL, is symmetric digital subscriber line. Next, number number one type of DSL technology is Rate Adaptive Digital Subscriber Line, or RADSL. RADSL is a pre-standard symmetric digital subscriber line solution, or RADSL technology was formerly described by ANSI in T1 TR 59 to 1 1999. RADSL supports downstream data rates up to approximately 8 Mbits, upstream data rates approximately 1 bit or s, and coexist with bots voice on the same line. RADSL allows rate adaptation while the connection is in operation. Rate adaptation during connection setup is possible in many other DSL variants, including DMT, and its successors. Rate adaptation while the connection is in operation is specified as an option in ADSL2, ADSL-L2 plus, and BDSL2 under the name Seamless Rate Adaptation, or SRA. In RADSL, the baud rate, center frequency, and constellation size of the downstream and upstream channels can be adjusted while the connection is on operation. Using this technique, the line is more tolerant of errors caused by noise and signal loss. As the parameters are adjusted, the bandwidth may be markedly decreased if there is a large amount of line noise or signal degradation. Next is asymmetric digital subscriber line, or ADSL. This is a type of digital subscriber line technology, a data communication technology that enables faster data transmission over copper telephone lines than a conventional voice band modem can provide. ADSL differs from the less common symmetric digital subscriber line technology technology that facilitates fast data transmission at a high bandwidth on existing copper wire telephone lines to home and businesses. Unlike regular dial-up copper telephone line service, ADSL provides continuously available, always on broadband connections. Next one is ADSL Lite, or G-Lite. This is an ITU standard for ADSL using discrete multi-tone modulation. G-Lite does not strictly require the use of DSL filters, but like all variants of ADSL generally functions better with splitters. Also, G-Lite is sometimes referred to as splitterless ADSL because of a data splitter is not required at the customer premises to split the voice and data signals being carried over the line. This is a different from normal ADSL, which uses a plain old telephone service, or what you call PATS, splitter at both the customer premises and the telco's central office, or CO, to separate the voice and DSL bands for transmissions over the phone line to prevent them from causing interference with each other. Next is high bit rate digital subscriber line or HDSL. This is a telecommunications protocol standardized in 1994. It was the first digital subscriber line technology to use a higher frequency spectrum over copper, twisted pair cables. This is also a technology is a transparent replacement for T1 repeated line. It allows DS1 signals to be transported over distances up to 12,000 feet or 3,700 meters on unconditioned copper cable, which are cables without line repeaters. And HDSL is easier to maintain and provision than conventional T carrier span designs because HDSL requires a repeater only at both ends of the line, not every 1,800 meters or 6,000 feet as required by conventional T1 lines. ISDN Digital Subscriber Line, or what we call IDSL. This uses IDSN-based digital subscriber line technology to provide a data communication channel across existing copper telephone line at a rate of 144 kbit, slightly higher than bonded dual channel ISDN connection at 128 kilo. The digital transmission bypasses the telephone company's central office equipment that handles analog signals. IDSL uses the ISDN grade loop without basic grade interface in ISDN transmission mode. The benefits of IDSL over ISDN are that ISDL provides always-on connection and transmit data via a data network rather than the carrier voice network. The limitations of IDSL is that the customer no longer has access to ISDN signaling or voice services. But for the internet service providers who do not provide a public voice, IDSL is an alternative way using POTS dial service to offer higher speed internet access, targeting the embedded base more than 5 million ISDN users as initial market. And lastly, the Symmetric Digital Subscriber Line, or SDSL. This is a digital subscriber line that transmits the digital data over the copper wires of the telephone network, where the bandwidth in the downstream direction from the network to the subscriber is identical in the upstream direction from the subscriber to the network. This symmetric bandwidth can be opposite of the asymmetric bandwidth offered by asymmetric digital subscriber line ADSL technologies, where the upstream bandwidth is lower than the downstream bandwidth. The SDSL is generally marketed at business customers, while ADSL is marketed at private as well as business customers. Also, SDSL supports the data rates up to 3 Mbps through a single pair of copper wires running from a telephone company. It has a maximum range of 3,000 meters and uses the entire bandwidth. And SDSL cannot be combined with conventional voice service on the same channel. Next one is the broadband technologies. Let's talk about broadband technologies and what is broadband technologies. Also, what is the types of broadband technologies? Let us discuss that later. So, what is broadband technologies? Telecommunication devices, lines, or technologies that allow communication over a wide band of frequencies, and especially over a range of frequencies divided into multiple independent channels for the simultaneous transmission of different signals. Broadband systems allow voice, data, and video to the broadcast over the same medium at the same time. They may also allow multiple data channels to be broadcast simultaneously. In the context of internet access, the term broadband has to come to mean internet speeds faster than those that could be achieved through dial-up. Now let's move on to the types of broadband technologies. The first one is cable modem. Cable modem services enables cable operators to provide broadband using the same coaxial cables that deliver pictures and sound to your TV set. Subscribers can access their cable modem service by simply turning on their computers without dialing up an ISP. You can still watch cable TV while using it. Transmission speed vary depending on the type of cable network and traffic load. Speeds are compatible to DSL. The next type of broadband technology is fiber. Fiber optic technology converts electrical signals carrying data to light and sends the lights through transparent glass fibers about the diameter of a human hair. Fiber transmits data at speed far exceeding current DSL or cable modem speeds, typically by tens or even hundreds of Mbps. Next one is wireless. Wireless broadband connects a home or business to the internet using a radio link between the customer's location at the service provider's facility. Wireless broadband can be fixed. Also, wireless technologies using longer range directional equipment provide broadband service in remote or sparsely populated areas where DSL cable modem service would be costly to provide. Speeds are generally comparable to DSL and cable modem. An external antenna is usually required. Next one is the satellite. Satellite is just a satellite orbiting the Earth provide necessarily links for telephone and television services. They can also provide links for broadband. Satellite broadband is another form of wireless broadband and it's also useful serving remote or sparsely populated areas. Downstream and upstream speeds for satellite broadband depends on several factors, including the provider and service package purchase, the consumer's lines of sight to the orbiting satellite, and the weather. Typically, a consumer can expect to receive at a speed of about 500 kbps and send at a speed of 80 kbps. This speed may be slower than DSL and cable modem, but they are about 10 times faster than the download speed and dial-up internet access. So service can be disrupted in extreme weather conditions. And lastly, the broadband over power line or the BPL. BPL is a delivery of broadband over the existing low and medium voltage electric power distribution network. BPL speeds are comparable to DSL and cable modem speeds, but BPL can be provided to homes using existing electrical connection and outlets. BPL is an emerging technology that is possible in very limited areas. It has a significant potential because power lines are installed virtually everywhere, alleviating the need to build new broadband facilities for every customer. So that's all to my report. Thank you for listening.